This paper is about whether the hypothesis of distributed cognition, as it is debated within philosophy of mind, can guide research within cognitive science. So I want to start by first introducing the even broader metaphysical assumption of active externalism, which claims that the material realizers of mind and cognition are not necessarily restricted to the agent's organismic machinery. Now, this metaphysical assumption usually comes in three main forms. The first one is the hypothesis of extended cognition, which claims that cognitive processing might extend beyond our brains to the artifacts that we interact with. The second form is the hypothesis of the extended mind, which claims that mental states such as our beliefs and desires might extend beyond our brains to the artifacts that we interact with. And finally, we have the hypothesis of distributed cognition, which claims that occasionally cognition might be distributed between several individuals along their artifacts, thereby giving rise to distributed cognitive systems that manifest cognitive properties over and above the sum of the cognitive properties possessed by their individual members. Now, these are similar hypotheses in the sense that they all argue that cognition is not brain-bound, and historically they have also entertained similar argumentative support, but here I want to mainly focus on the hypothesis of distributed cognition, and specifically whether it can guide research within cognitive science. Now, why might we think that active externalism in any of its forms can guide scientific research? Well, think about Imre Lakatos, who is perhaps one of the most important philosophers of science of the previous century, who argued that in the hardcore of every scientific research program, there lies a metaphysical assumption that is responsible for providing the research program with its identity. And so the idea here is that active externalism can act as precisely such a metaphysical assumption in order to guide a broad scientific research program that will be open, at least in principle, to the possibility that cognition can be realized by non-biological processes that stretch beyond the boundaries of brain and body. Now, as it happens, already a good amount of work within cognitive science seems to be at least implicitly guided by active externalism in the form of the hypothesis of distributed cognition. So, for example, I have here in mind studies on modeling and understanding swarm intelligence and the collective behavior of animals, as well as studies on the emergence of human collective behavior such as sports teams' performance and rhythmic coordination. And even though such studies are not always open about accepting the claim that collective behavior is cognitive behavior, some of them are quite explicitly open about this possibility. So, for instance, in a very interesting study published in Cognitive Science, Cook et al. Claimed that the term cognition used in the team context refers to cognitive processes or activities that occur at a team level. Like the cognitive processes of individuals, the cognitive processes of teams include learning, planning, reasoning, decision-making, problem-solving, remembering, designing, assessing situations. Teams are cognitive dynamical systems in which cognition emerges through interactions. And yet, there still seem to be, within philosophy as well as science, several people who remain skeptical. So what I want to do in this paper is to try and alleviate some of their concerns by responding to a potentially worrisome objection that might be raised against the view. This is what I will refer to as the objection from psychofunctionalism, and which has already been raised against active externalism in the form of the hypothesis of extended cognition and the extended mind thesis. So my question here is, can it also be raised against the hypothesis of distributed cognition, and should we worry about it? So, first of all, I will explain a little bit how one might argue for the hypothesis of distributed cognition, and then why we might worry about the objection from psychofunctionalism. Then, in order to explain why we shouldn't worry, I will take a look at the way big colonies reach decisions, and then finally I will conclude. So, the hypothesis of distributed cognition can be motivated in several ways, but a rather popular one, and which I will refer to as the standard argument for the hypothesis of distributed cognition, comes in two main steps and a conclusion. The first step is to identify a case where several individuals integrate with each other in a distributed system to realize a certain behavior. The second step is to demonstrate that the relevant behavior can be readily accepted as cognitive behavior. And then if those steps are satisfied, then we can finally conclude that there exists a distributed system consisting of all participating individuals that realizes a cognitive behavior. In other words, there exists a distributed cognitive system. Now, the first premise can be defended on the basis of dynamical systems theory, which claims that when several systems mutually interact with each other in an ongoing way, there emerges a non-decomposable coupled system that consists of all of them at the same time. This is an idea that Clark and Chalmers introduced. Semero also talks about it, and I also have extensively argued for it in another paper, so I'm not going to focus on it here. Instead, what I'm interested in is the second premise, which tries to establish whether the relevant distributed behavior can qualify as a distributed cognitive behavior. So the question is, how do we judge whether a given behavior may qualify as cognitive? So the way proponents of active externalism usually attempt to establish this is by invoking the approach of common sense functionalism, according to which the way to identify and categorize mental states and processes is by using our common sense folk psychological understanding of them. So, for instance, if we want to claim that a group of people as a whole can remember stuff, then if we were to rely on common sense functionalism, all we would need to do would be to find a group that appears to collectively encode, store, and retrieve information. And the reason why this would be enough is because on the basis of our common sense, this is what a memory system is supposed to do. Simply encode, store, and retrieve information. Now, say that we did come up with a group of people that collectively encode, store, and retrieve information. The problem is that opponents of active externalism could still argue that the group does not really remember unless it also manifests the generation, negative transfer, recency, and primacy effects. So, what are these effects and why should we care about them? They are regularities of behavior, usually referred to as psychophysical laws, that we have observed when we carefully study the way the human brain remembers. And the idea is that these regularities of behavior or psychophysical laws are defining features of what it means to genuinely remember. And so any process that fails to manifest these psychophysical laws won't qualify as a genuine memory process. So for instance, think about the primacy and recency effects, which refer to the fact that when we are given a list of items to recollect, we're more likely to recollect the items that appear in the beginning and in the end of the list rather than the items that appear in the end. And so the idea is that any process that is supposed to count as a memory process won't qualify as such if it fails to manifest these effects. And in fact, Rupert, Adams, and Eiswager have in the past used such psychophysical laws in order to argue against the idea that memory can extend when we use a well-organized notebook. Because if you think about it, if we were to recollect a list of items by using a notebook, then we will not manifest neither the recency nor the primacy effect, because we would be able to recollect all the items on the list equally well. So basically, by arguing in this way against active externalism, what those opponents of the view are essentially doing is that they are invoking what is known as psychofunctionalism, which is an alternative to common sense functionalism, and which claims that when we try to identify and categorize mental states and processes, we shouldn't use our common sense intuitions about them, but instead we should use information that we have derived on the basis of careful scientific experimentation. And so the idea is that if we use psychofunctionalism, if we did use detailed, scientifically derived information about what a mental state and process is supposed to be, then we wouldn't be able to find any extended or distributed cognitive processes. Now, in general, it is not clear, and it is very much an open debate about whether we could indeed give up common sense functionalism for the sake of psychofunctionalism. However, I will here assume that we can, and that perhaps in the future we would only have to retain psychofunctionalism in order to see whether this would actually generate problems for the hypothesis of distributed cognition. Consider the way bee colonies reach decisions about nest locations. So in spring, bee colonies of the European honeybee reproduce via fission. And what happens is that the old queen leaves the nest and she takes with her thousands of scout bees. And in this process, those scout bees, they start exploring the surrounding environment in order to find a new nest location. When a bee finds a potentially good site, she returns to the colony in order to advertise this nest site. And when a bee that advertises a given site meets another bee that propounds an alternative site, she might receive a stop signal. And if she receives many such stop signals, then she might revert to an uncommitted state. Now, this is an ongoing cyclical process during which bees continuously affect each other on the basis of recruitment and stop signals. And this cyclical process eventually comes to an end when bees committed to the same nest site reach a quorum. Now, Reina and colleagues have recently published a paper in Scientific Reports where they report that they have run computer-based stochastic simulations of a model representing the way bee colonies reach decisions. And they argue that their simulations demonstrate that the superorganism's decision-making process manifests the same psychophysical laws that human brains obey when they engage in decision-making. So what are these laws? The first one is Weber's law, which says that the brain can detect the option of the best quality when the difference between the values of the quality selected from is above a minimum value, and that this required minimum value increases as the value of the compared qualities increase. So this is why we are really good at telling the difference between a set of 5 dots and a set of 10 dots, but we find it really hard to distinguish between a set of 95 and a set of 100 dots, even though in both cases the difference between the options is only 5 dots. The second psychophysical law that describes human decision-making is Pierron's law, which claims that when two options are of high quality, the brain reaches decisions faster compared to when the two options are of lower quality. And the last psychophysical law is Hick-Hyman's law, which claims that the time the brain requires to reach a decision increases as the number of options increases. So as it turns out, Reina et al.'s model manifested the same linear dependence between the required minimum quality difference between options and their mean quality as predicted by Weber's law. It also agreed with Pierron's law because the model was faster to decide between two nest locations of high quality compared to two nest locations of low quality. And it was also in agreement with Hick-Hyman's law because the model of the bee colony took longer to reach decisions when the amount of alternative nest locations increased. So based on this, Reina et al. Conclude that the study shows for the first time that groups of individuals, in their case honeybee colonies, considered as a single superorganism, might be able to obey the same laws. And similarly to neurons, no individual explicitly encodes in its simple actions the dynamics determining the psychophysical laws. Instead, it is the group as a whole that displays such dynamics. So going back to the second premise of the standard argument for the hypothesis of distributed cognition, we now have a decision-making behavior that is distributed and which obeys the same laws as human decision-making when this is studied on the basis of careful scientific experimentation. So in other words, if we were to run the argument for the hypothesis of distributed cognition in the case of bees, then the second premise of that argument would still be satisfied even if it invoked psychofunctionalism instead of common sense functionalism. So to conclude, even though it is not clear whether we could give up common sense functionalism, even if we did have to abandon this approach to philosophy of mind and instead only retain the alternative of psychofunctionalism, proponents of this alternative view should still remain open to active externalism, at least in the form of the hypothesis of distributed cognition. So overall, what this means is that the hypothesis of distributed cognition can act as a guiding metaphysical assumption at the hardcore of scientific research programs, no matter whether these are to be further paired with common sense functionalism or the more scientifically demanding psychofunctionalism.